Hi all, welcome back to Whoops with C++ session 39. So this is the third exception handling session. If you have not watched session 1 and session 2, please watch it and come back to this one, session 39. Today's session we will discuss about automatic stack unwinding, generic cache block and rethrow. Okay, so now let's start with automatic stack unwinding. So what do you mean by stack unwinding? So generally, whenever any CPU control enters into the function definition, all the local variables which are declared, they will get the memory. And whenever the CPU control is coming out of the function definition, all the local variables will which got the memory inside that function that will be removed from the stack frame. So this is the normal procedure. Now, what do you mean by automatic stack unwinding with respect to exception handling? So, for example, you have suspected some of the codes or one or two lines of the code that might throw an runtime exception or runtime errors that is nothing but an exception. So, and before those particular lines, you have created some local variables or maybe some objects you have created, and there will be some situations where some within before coming out of the try block itself, you have encountered the exception and the try block won't execute completely. So during that time, what will happen is before throwing the exception, what will happen is all the local variables or local objects which got memory inside the try block that will be removed from the stack memory. Okay, so that's the concept of automatic stack unwinding. So whenever any exception occurs inside the try block, then before throwing the exception from try block to catch block, all the local variables or objects which got created in try block will be removed from the stack frame. So even though the CPU controller is not hitting the closing curly braces of the try block, so then all the local variables will be removed from the stack frame. So assume we have created an object inside the try block. Then before throwing any exception from the try block, first the object will be removed from the stack frame, and for that destructor will be called. So we know that whenever the object is going out of the scope, then destructor will be called further. Okay, so then let's have some program for this to understand. Okay, so this I have a class called class my class, and it is having one constructor and destructor. Whenever object is created, constructor will be called, and whenever object is going out of scope, destructor will be called. And I have a division function which is checking if denominator is equals to 0. If it is equals to 0, we are throwing the exception called divisible by 0 is invalid. That is a constant character star. If the denominator is not equals to 0, then we are returning num by numerator by denominator. So this is my main function. So first I am asking user to enter numerator and denominator and taking the values numerator and denominator. So now this is the block. Now try block is started. So now what I am doing is just I have created one object, my class object. So whenever object is created, first object memory will be allocated for this object, and that initialization will takes place with the constructor. So constructor will be called for the object while creating. So this statement will be printed. So later what I'm doing is I'm calling so division. Just one second. Yeah. So here I am calling division numerator denominator. So now what it will do is it will go to this function. It will check if the denominator equals to 0. If it is not equals to 0, then you will get the proper value. Then if we have entered a denominator as 0, so then it will throw the exception. So but this particular line exception is thrown, then what will happen is before throwing the exception, so we know that whenever an exception occurs inside the try block, the rest of the statements won't get executed, right? So now this particular line exception is occurred, so then immediately exception will be thrown from this try block to suitable catch block. But before throwing that exception from this line, it will check so whether any local variables or local objects which got memory or which got created here. So yes, there is a object of type class my class is created inside the try block, so we have to remove this one. So for removing this, when it is so means this object has to go out of scope. When this object is going out of scope, destructor will be called. Okay, so now we can see that this build this program, rebuild it, execute it. Okay, so first let's give some proper values. So 10 comma 2. So you can see constructor. So first enter numerator, denominator. So we have entered the values. So inside the try block we are entering. Inside the try block, I have created an object for my class object. So constructor will be called for this. After that we are calling the division function. So in the division function we are passing denominator, numerator, that is numerator, denominator 10 comma 2. So here denominator is not equals to 0. So return numerator by denominator, that is 5. So that is executed. Next end of try. Now the CPU control is going to hit the closing curly brace of try block. So during that time all the local variables which got memory will be removed from the stack. Okay, so now this my class object is got created, and for this object destructor will be called. You can see that destructor. So after that, since there is no exception occurred, what is happening is so none of the catch blocks will execute, and the last statement will be executed, that is end of main. Okay, this is the normal flow. No problem here, right? So now we'll see the exception. Let 10 comma 0. So now see what will happen. See the magic now. Okay, so 10 comma 0 we have entered. So numerator my class object is created. So for this creation constructor will be called, correct? So next denominator, division, numerator, denominator, correct? So here it is checking denominator equals to 0. So throw exception. Now exception is thrown from this line. So then what will happen? So none of the statements after this division, none of the statements here it won't execute, right? So now what will happen is before throwing the exception from here, it will check whether any local objects or local variables got created. Yes, the local object is got created. So what it will do is it will throw the, before throwing the exception, destructor will be called for this object. So that's why you can see destructor. So you cannot find this end of try, because we can, from this it is clear that CPU is not executing this line, this statement. So if it is not executing this statement, then this particular step won't execute. Correct. So automatically destructor will be called for this. All the local variables, all local objects will be removed from the try block, right? So that's why destructor is called for this. Next you can see this particular catch block is executed. Divisible by 0 is invalid. After that, end of main. Okay, so this is called automatic stack unwinding. So that is the reason it is always advised, instead of writing self-defensive coding like if else conditions, provide use C++ concept, that is try catch blocks for better memory handling. Okay, so now, so that's about automatic stack unwinding. So next come another interesting concept, that is generic catch block. Generic means generic, it is generic for everything. Okay, a catch block. So a catch block which is able to handle all types of exceptions or all types of exceptions is called generic catch block. So generic catch block has to be kept as the last catch block in try catch sequence. So only thing is generic catch block will take any type of exception it is throwing from the function, excuse me, it will handle. So now what we have to do is, whenever you are providing the catch block, generic catch block, you have to keep it as a last option, and you have to keep it as a last catch block in the catch block sequence. Okay, so coming to the syntax of this generic catch block. So first provide try block, and so try block will the responsible to throw the exception. And now from this try, after this try block, whatever catch blocks you can think of, write all the catch blocks, and at the end only you write the generic catch block. So what is the arguments for generic catch block? Catch block with three dots. So this is the generic catch block. Always it should be the last catch block. So if you have kept it somewhere in between, so then you can clearly get the compile time error. Okay, so this is the possible catch block. Even though see, it is always advised to provide all the possible type of exception handlers. Okay, all the type of catch blocks won't at the end only if still you are unaware what type of exception the function might throw or try block might throw, then only you go for generic catch block. Okay, now so let's see one program for this generic catch block also. So to this will disable this generic catch block. Yes. Okay, so here same division function I have taken for better explanation purpose. So here denominator is equals to 0, then we are throwing an exception, that is constant character star type exception we are throwing. So if this particular catch block is not available, then generic catch block will execute. Since it is available, this particular thing will execute. This particular exception will execute divisible by 0. Okay, now let's run this program again. So, 10 comma 0. You can see, so 10 comma 0 divisible by 0 is invalid. This particular exception is caught by this catch block and same exception is printed here. Okay, so now what I will do is I will try to change it to throw an integer exception. Okay, so if I am throwing integer exception, then what will happen? Integer catch block will execute, right? So you can see I have it is showing 0 as the exception, that is integer value. Cout divisible by what is the value it got, that is 0 is invalid. So this particular thing is executed. Now assume what we'll do is I will comment this code. So don't provide the generic catch block. Sorry, don't provide the integer catch block and don't provide the generic catch block. Okay. So now maybe assume that you have written all the possible catch blocks for this try block. But what you are doing is you are trying, you thought you have implemented all the catch blocks. Okay. Now there is a chance. So now you can see. So whatever possible catch blocks, assume that you have implemented all the possible catch blocks, whatever is possible. But from the function, it is throwing the exception which you are not written to catch, right? So during that time, what will happen? This unhandled exception will lead to terminating the abnormal termination of your program. So to avoid that, what we'll do is we'll write the generic catch block, because now my function is throwing integer catch block. I don't have integer catch block. Okay, it will throw the exception. Alright, now again we will write 10 comma 0. So now you can see generic catch block is executed. So now here I am throwing 0. So first it will check whether the CPU controller will check where to transfer the control. So this catch block is constant character star. Is there any catch block which is taking integer? No, not there. So then it will look for generic catch block. So generic catch block is there. So generic catch block will execute exception. Okay, it will take this and write this exception. Okay, but it is always advised to write all the possible catch blocks. So generic catch block, it will just display you message that some exception occurred. Why that particular exception is occurred, we don't know, right? So it will be sometimes you will be trying to access some website, then you will get unhandled exception or some error happened. Okay, if you will get some generic messages. With that you won't come to know what is happening, whether my internet is problem or website is down. So we don't know that there's some generic message will come, right? So to avoid that, write all possible catch blocks. If after that only you provide the generic catch block, right? Now, after the generic catch block, we have another interesting concept called rethrow. So that is whenever you have got the exception in the try block, from try block to catch block, from the catch block again you can throw back the catch to another catch block. So you can transfer the exception from one catch block to another catch block only when you have a nested try catch blocks. So when exactly, so rethrow means whatever exception you have got, you are rethrowing the same thing. Okay. So why exactly it is required? So for example, you have some scenario like this. You have some username and password you have entered in the GUI, and you have given okay. So when you give okay, it from GUI there is a GUI interaction code. It will take the username and password, and it will be given to the business logic code. What this business logic code will do is it will connect to the suitable database, and from there it will get the value. Assume there is sometimes what will happen is maybe the database is not available, or maybe the connection got terminated to the database. During that time what will happen, a runtime exception will happen, so saying that so connection got terminated or there is no database is down. Okay, so now database connection lost, that exception came, that exception you have to give it to GUI interaction code. Same exception it has to be given to the GUI to display it, right? So now the exception is occurred in the lower layer. From lower layer, the same exception is transferred to the middle layer to higher layer it will be transferred. So whenever you want to transfer the exception from lower layers to higher layers, you have to this rethrow is very very useful. Okay, so whatever exception is occur, you don't suppress in the lower layer itself, you just give the intimation to the uh, application layer also why exactly the issue happened. Okay, so now what exactly we are doing the in rethrow. So throwing an exception from one catch block to next successive catch block is called rethrow. Okay, and the rethrow is possible only in nested try catches sequence. So then what do you mean by nested try catches sequence? Say here I have try catch. Okay, now I'm calling a function rethrow demo. Okay, this rethrow demo is also having the nested try catch block, try catches. Okay, means inside this try you have another try catch blocks, right? So you can throw the exception, say you cannot throw the exception, rethrow the exception from one catch block to another catch block in the same catch block sequence. But what you can do is you can throw same exception from one catch block to other catch block where it is called the function. Okay, so this is one layer, library layer, this is application layer, right? So now what I'm doing here, I'm throwing the exception. So the suitable catch block will be executed, just provide throw semicolon. So what it will do is whatever exception this catch block got, same exception will be thrown outside the function. Okay, so you can but this is not possible from one catch block to another catch block in the same catch sequence, it is not possible. But you can rethrow the same exception from one catch block to another catch block if they are in nested. Okay, so just have a program. Let's discuss one program for this. Just rebuild it. Okay, so you can see here what I'm doing is I've denominated, I have a try catch blocks here. So I'm throwing a constant character star. Uh, so constant character star. This particular exception will occur. This one will execute. Okay. So again I'm throwing the exception. Okay. So here I'm throwing constant character star. So here I don't have constant character star catch block, right? So now what will happen is here constant character star you are throwing, but here constant character star is not there, so it will execute the generic catch block. Okay, so now run this program. 10 comma 0. Anyway, with the values, it will proper values, it will work, no issues. So first enter numerator and denominator. We have entered. We are calling division numerator denominator function. So then the control will jump here. So it will check. The control will check if denominator is equals to 0. Yes. So then it will throw the exception, that is divisible by 0 is invalid. So this is a constant character star. So then you can see exception thrown from division function. Exception thrown from division function. So now again we are throwing the same exception. What is the exception we got? We got constant character star exception. We are throwing the same exception. So now again what it will come? So here again CPU controller will check is there any catch block which is taking constant character star, because here we are throwing the exception whatever we got. So we got only constant characters of star. So same exception will be thrown. But since here there is no catch block which is having a constant character star as argument, so this generic catch block will be executed. You can see unhandled exception caught from division function. Okay, so that is the thing. Now what we'll do is, if you want, see this is actual rethrow. But what you can do is you can throw other than the caught exception also. So you have got a constant character star, but you are throwing another exception, that is integer exception. Now you can see here exception thrown from division function executed. Now you are throwing integer. So integer catch block is there. So then it will execute divisible by 0 is invalid. Okay. See here, I have entered 10 comma 0. So with 10 comma 0, the function is invoked. So denominator equals to 0. Yes, throw the constant character star exception. So this exception is from division function. Yes. So here I am throwing integer. That integer will be caught by this catch block, and this particular thing will be executed. That is divisible by 0 is invalid. So this is about rethrow. Okay. So that's about for today. That is generic catch block we have discussed. We have discussed automatic stack unwinding, and we have discussed rethrow. See, automatic stack unwinding is the main advantage why we are moving for uh, um, C++ based try catch blocks or object oriented based try catch blocks for exception handling instead of self defensive coding. Okay. So that's for today. Thanks for watching.